You ready to go, right?
Yeah. Funding for today's broadcast, as well as the following message, is brought to you by Culture Hacking. Do you have a message that you would like to broadcast, but conventional social exchange makes conveying your ideas difficult? Try Culture Hacking today with one of our low-risk 30-second trials. Find an open mic near the audience of your choosing. We recommend raising your hand at a Q&A session, and then just tell people what you want them to know. Culture Hacking, it's what you're about to watch.
This is the INCOSE Lightning Round Radio Show, and I'm your host, Robert Stevens.
I think because language really demand language.
More exciting, more dynamic, more joyful than any other way we've achieved to live our lives.
Sort of what a group of engineers would be able to help.
Good afternoon and welcome to the inaugural live broadcast of the INCOSE Lightning Round Radio Show. I'm your host with the most, DJ RC Stevens. Our guest today is INCOSE's very own Dr. C. Robert Kenley. He's got over 30 years of systems engineering experience, and he's here today to talk about the importance of empathy in engineering complex systems. Professor Kenley, thanks for coming on the show today.
My pleasure.
Yeah, so you teach a few courses at Purdue. One of them is Systems 530, Practical Systems Thinking. Students take this class hoping to gather some concrete lessons to take back to their workplace as opposed to the more theoretical jargon they're getting in a lot of other classes. A large part of this course deals with coordinating and executing a project to help a community sponsor. Now, I don't find it intuitive that a group of very mathematically minded engineers would be able to help groups like sports franchises and religious groups.
Well, the students don't normally think they can either. But the systems models that we teach are used by social scientists and consultants to help organizations like churches and nonprofits every day.
These tools seem pretty useful.
Oh, yes they are. Well, let me tell you something. At the end of the Cold War, I worked in a group that used similar methods for stabilizing nuclear materials across the United States. Yes, we weren't able to be quite as straightforward as we are in the class about the models we were using. We didn't say we were doing soft systems engineering at the time, but we did traditional engineering trade-off study work that included soft elements. We use factors like technology readiness, technological performance, risk to the public, acceptability to the public, and so on. In order to comply with environmental regulations, we went to environmental hearings to discuss our work. And guess what? After we presented, the public was excited about nuclear waste. Because we were good systems engineers and had done all of this soft system type of work ahead of time, the crowd said, "Hey, this is great. You did the analysis we expected you to do. Then you picked the alternative with the lowest risk to us." So when implementation started, there were no big demonstrations or laying down in front of bulldozers at the plant. The Rocky Flats plutonium manufacturing plant was knocked down and turned into, well, it was a brown field, not a green field. It's still a little hot, but let me tell you, all the materials that were bad were shipped out and the buildings were gone.
Oh, so you anticipated the questions and concerns of the citizens before they even had a chance to ask, and that ensured the success of the overall system?
Yes, we did.
Huh. And students at Purdue are learning these methodologies right now?
Right now as we speak.
Excellent. So before you were professor of practice at Purdue University, say that 5 times fast, you were working in MIT in their Socio-Technical Systems Research Center, right?
That's correct.
Awesome. Could you tell our audience a little bit more about that?
Well, that was the Lean Advancement Initiative at MIT, and they were focused on enterprise architecture, which was done following some Air Force contracts they worked on. They decided that the key to process improvement was not necessarily doing just value stream mapping and all that good Six Sigma lean stuff, but it was actually defining the whole organization, how it worked, and innovating on the architecture of the organization. Let's give a shout out to Dr. Donna Rhodes, our INCOSE colleague, who was one of the principal researchers there. So yeah, I joined them to work on activities like that.
Cool, so you're kind of improving the process of process improvement.
Oh, you got it.
So you were teaching a course there as well, or did you?
Oh, no. At MIT, it's just full of doctoral researchers working on large research projects, and we had about half a dozen of us that did nothing but research and helped graduate students in their research.
So you're researching at MIT. What leads you to Purdue?
Well, there was a project I worked on with a master's student there applying technology readiness, and we were forecasting technology availability. I was at a conference at the Naval Postgraduate School, and there I met Dr. Dan DeLaurentis of Purdue. He and I agreed that it was time for me to come to Purdue, and when I came, we were doing research in systems of systems. Soon they found a faculty position for me because they were getting started with their systems courses under the auspices of what is known as the Purdue Systems Collaboratory.
Oh, so you started Purdue in 2014?
Well, yeah, I was a faculty member, but I actually joined Dr. DeLaurentis in 2012 as a researcher and had about 3 or 4 other PhDs who were running research projects and working with graduate students. It was very similar to the MIT environment I come from.
So you get to Purdue in 2012, but you didn't start teaching until 2014?
No, kinda. I actually started teaching in 2013. A colleague of ours had a design class in Aero, and he was really busy on a big research project, so they asked me if I would teach his class. It was a systems engineering class, except it was all about design in aerospace engineering, and it happened to have a lot of mechanical engineers and other non-aero people, because the principles were systems principles that are applied across engineering.
So your teaching in aerospace systems course, did that have any human elements to it?
Oh, yes, it did. It was a design course that was very similar to the course we're doing now. All of the good engineering methods we teach today came from that aero course. Now they've been adapted to be taught to any student in any major. As a matter of fact, we're even teaching doctoral nursing students this summer.
So you're teaching a class of nurses at the same time you're teaching engineers?
Yes.
And have you noticed any big differences between the two?
Of course. Well, the nurses have empathy right up front, whereas the engineers learn empathy through using the methods that we give them. The nurses are a little bit leery about the cybernetic models and all of that, and all that engineering stuff, but they understand people quite well.
So in a way, the nurses are better socio-technical systems engineers due to their higher emotional intelligence?
Very much so.
So in addition to teaching a class of nurses, you're also teaching a class in a different format than a typical lecture?
Yes, we do this with online students. Sometimes the students are all online. Sometimes there's a mixture of about 2/3 online, 1/3 on campus, and we force the online students and on-campus students to be together in the same project teams.
Oh, so it's totally possible for a student to go through the entire course without ever seeing another person?
Well, technically, yes, but they do see the image on the screen during WebEx meetings.
So do you notice any major differences between the on-campus students and the online students?
Oh, not so much. The course is really rooted in the emotional intelligence at the point of origin.
So in the first 2 weeks, they start working on, you call them modules in the syllabus. Could you tell the listeners a little bit more about that?
Well, they do a lot of reading, which for engineering students is a real pain. Then they complete a question and answer session to force them to do the readings and actually process the points. And they learn about all kinds of system methods that they will be applying on those projects.
And do the nursing students like this? Or?
Yeah, they'll put up with anything. They're nursing students, okay? So,
and the engineers?
The engineers, well, some of them swear it's just a bunch of busy work and they have no idea that they're actually learning methods and processes before they apply it.
Oh, so they're learning the methods before they meet their community sponsors?
Yes. By the time the students meet with community sponsors, they already know all the systems engineering lingo and all the cybernetics lingo, even though they've been force-fed what they think is a nothing burger. They find out when they go to the projects that they learned a lot by doing that heavy reading and module work. And we start with the cybernetic feedback model, the basics, okay? Then they learn about one of the most important models, the viable system model by Stafford Beer. It describes how an organization operates, and it's generic enough that it can be applied to everything from a nonprofit, very small nonprofits, to major corporations like United Steel, where Beer worked when he developed this. You can even apply it to a university. It uses the concept of cybernetic feedback to describe how an organization operates. We spend a lot of time on this model and give several examples to show how generic that model really is. We modeled a for-profit company, we modeled Purdue University, we modeled a nonprofit agricultural cooperative in the UK, and we even modeled a business school. Most of the project teams will have projects similar to one of these sorts of applications. So I like to make sure they've seen the viable system model applied to their area, viewed from all kinds of angles. Well, now the nurses, they got a little bit upset with me because I didn't have a hospital example, and they were threatening to go out on strike. Well, guess what? I went out and found a hospital model for them to review. And they really appreciate that I found it for them, and the future nurses will benefit from this current crop of nurses going out on strike for a while.
So you change the course as you go?
Well, yeah. At a land-grant university like Purdue, we like to think it's about discovery, learning, and engagement. We call it learning rather than education because we want it to be bi-directional. The faculty learn from the students, and then we change how we educate them, and then occasionally a research student changes everything about how we're thinking.
Are there any particularly big lessons that you personally have taken away from the course just by teaching it?
Well, yeah, you'd be really surprised when a student's asking for something. Well, sometimes they're just being selfish to get a grade, of course, but they actually may have a breakthrough idea.
What sort of ideas are we talking about?
Well, just earlier today, across the way, a former student of mine, Ibukum Phillips, presented his work, which combined two methodologies that no one ever thought of combining. He developed this while he was taking classes and looked at different ways of approaching problems. The light bulb went on in his head, and one night on campus, and he came back to me the next morning, and he published a paper on soft systems and TRIZ merged together. I was shocked. And then, of course, the nurses, they forced me to find out about specific examples and system methods in healthcare that I had been totally previously unaware of.
What kind of systems thinking methods are we talking in healthcare?
Well, for one, we found an interesting take on UML activity diagrams in a medical journal. Yeah. I don't remember what for exactly. It had something to do with emergency rooms and orthopedic surgeons. But the takeaway was they got rid of the swim lanes and changed the wording to make the diagram easier to follow, even though it was a very complex situation. And it required multiple resources to solve the problem. So there we go. Someone in the field outside of systems engineering probably has a good idea for us about how we should present our information.
Excellent. So someone from your media team sent us over a clip of you explaining what makes a great project in the class.
So, Dr. Kenley, do you have any examples of projects that really stick out?
Well, anything that's really different from the other projects.
So kind of like pretending to be on a radio show at the INCOSE International Symposium?
Yes, exactly.
So we actually had a project at General Motors that really stands out. If you just look at the diagram on the left there they developed, it looks like just the standard big company org chart for some ISO audit or something. And it showed all the work that was thrown on the engineers from management and how they were trying to organize the team. But the really successful part was that they were using a form of yoga instruction to improve the cybernetic flow of communication around that system and relieve the burden of the activity that was thrown on the engineers. Because the engineers didn't talk to each other much, the Beer Viable System Model spotlighted that. The idea of bringing yoga in to improve the networking of the organization was brought forward as the solution. So if we were some chemical engineers, we might say yoga was the catalyst to the reaction that they wanted.
Oh, awesome. Yeah. So in addition to the viable system model, you also teach Peter Checklin's soft system methodology. I'm told you've got an interesting insight into that particular method.
Yes, if you look at it, see the picture there?
It's a V.
Yeah, how about that?
Okay.
They're both laid out on the page in the form of a V.
So you're telling me that the traditional top-down systems engineering V model has made its way into soft system solution development?
Yeah, I talked with some people who were friends of Checklin back in the day, and They say they never knew that. I asked them, well, hey, did you ever notice it's in the form of a V? So they went back to the UK to check on that, and I'll get a report from them.
This is heavy, Doc.
Yeah, it gets heavier. Look deeper than the shape. If you look carefully at the steps, you start with a real-world problematic situation, you pick some useful parts to describe, and then you come down and then back up on the right-hand side of the process, and guess what you do? You compare the rich pictures from the left-hand side of the V to the conceptual models on the right-hand side of the V.
Like validation.
Yeah, you got it.
Okay.
Yeah, so when you come back up the right-hand side of the V, there's Checkman. He's got it. He's doing that validation and verification work.
Oh, man.
Right, I don't know about you, but that sounds a lot like a V model.
And there are Purdue students
Learning all this
right now.
right now.
Nice. So, what is the biggest takeaway that you want your students to have from Systems 530?
That there are soft systems which are guaranteed to impact our ability to actually get the hard system deployed into operation.
So, there are underlying human elements in every system,
Yep.
and they're going to matter whether we like it or not.
Yes, it could be the operators of the system, it could be the people who build the system, it could be the owner who's funding the system.
But you really need to factor everyone in?
Yes, or in the case of Rocky Flats, if you could have just been innocent bystanders, we could have ended up making you victims of the system if we hadn't considered your needs ahead of the time.
So this is pretty powerful stuff. Do you have a dream, or what's the biggest, hardest, most wicked problem you could solve using these methods?
I don't know.
So soft systems engineering methods can solve any problem? I mean, is there a limit to how useful these methods are?
I think not.
Well, that's all, folks. That's all the time we have for today. Be sure to like, comment, and subscribe. And until next time, I'm DJ RC Stevens, and this was the INCOSE Lightning Round Radio Show.